Welcome back. This is Mrs. Rubright with Advanced Geometry. Today's lesson is 4-7, Use Congruent Triangles. Alright, so explain how you can use the given information to prove that the hanglider parts are congruent. So, we need our statements and our reasons. So we have our statements and our reasons. So statement 1. Angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. Angle RTQ, we can write them together because they didn't give us a certain amount of points that we have to use, right? So like I told you guys on the quiz that you wanted to separate out your givens because they gave you that many lines to do so. So the second thing is RTQ is congruent to RTS. Alright, so that's what we know so far. Those were both given. We are trying to prove that QT is congruent to ST. Well, what do we know so far? Looking at the diagram, the only other piece of information that I know is that RT is congruent to RT. How do I know that? How do I know that RT is congruent to RT? Reflexive. So therefore, triangle RTQ is congruent to triangle RST, or sorry, nope, wrote it in the wrong order. RTQ, RTS. How do I know that those triangles are congruent? By angle, side. Right? What we just did in our last lesson? So now, I know that QT is congruent to ST. Well, let's look. QT, 3, 2, 3, 2, right? QT is congruent to ST. Corresponding parts of congruent triangles are congruent. CPCTC. Corresponding parts of congruent triangles are congruent. Okay? So you can initial that as CPCTC. Corresponding parts of congruent triangles are congruent. So basically, if you prove the two triangles congruent, then all of their corresponding angles, all their corresponding sides are congruent. So if you're trying to prove a corresponding side or a corresponding angle, all you do is prove the two triangles congruent, and then all of their corresponding stuff is congruent. Does that make sense? All right. So, just taking this one step further than what we've been doing. Explain how to prove that angle C is congruent to angle A is congruent to angle C. So the first thing I'm going to do is I'm going to list my givens. So AD is congruent to DC, right? Given. AD and DC was given. That's what I just showed you guys, this one, right? We also know that AB is congruent to BC because that was also given, right? What else do we know? Looking at this, I know that BD is congruent to BD. Why? Reflexive. Alright, so now I know that these two triangles are congruent by what? Side, 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 right? The two triangles are congruent by side, side, side. Since the triangles are congruent, their corresponding parts are congruent. So angle A is congruent to C. Those are not listed in the same order. Did they mess up on their listings? Probably, because it's your textbook publishers. So angle A is congruent to angle C for sure. Corresponding parts of congruent triangles are congruent. They do have an error here, though. Right here, A and C should have been in the same positions, right? They didn't write their congruent statement properly. So if they went A, B, D, they're going up 2 marks, up 2 marks, down 3 marks, right? Up 2 marks, down 3 marks. So up 2 marks, down 3 marks would have been C, B, D. This should have been listed as C, B, D. They need to write them in corresponding positions or they're wrong, right? Write them in it's a congruent statement. It needs to be written in corresponding positions. It's very important to do so. Are you guys okay on this? Perfect. So it's just kind of taking up one more step than what we had been doing. Use the following method to find the distance across a river from point N to point P. Place a stake at K on the near side so that NK is perpendicular to NP. So NK is perpendicular to NP. They told us that. That was given, right? Find M, the midpoint of NK. Well, if N is the midpoint, then this is two equal parts, right? Locate point L so that NK is perpendicular to KL. So we know that this is perpendicular. And then it tells us that these are all collinear. All right, so what is the whole point of this? So the point of this is, if I wanted to know the distance across the water, I don't want to have to like take out a measuring tape or something and actually go across the water to find this distance. But if I did these measurements on land, right, if I did the measurements on land, then I have two congruent triangles. I know that this measurement here is the same as this measurement here. I know this measurement here is the same as this measurement here. So doing this helps you not have to do the more difficult task of measuring over water. So vertical angles are congruent, right? Vertical angles are congruent. So by angle, side, angle, these two triangles are congruent, therefore their corresponding parts are congruent. And that's the whole point of doing this. And this is what surveyors do all the time. Do you guys ever see out in the streets those guys with those little sticks that have a little like camera looking thing, like a little lens? They're called surveyors. They're civil engineers that are trying to figure out, you know, where fire hydrants need to be when they're doing road work. If they're figuring out what happened because of an accident, they're surveying to find out different measurements. So like the curb has to be a certain amount, a certain distance from the street. Like there's, you know, specific widths of traffic lanes. There's widths of sidewalks. Fire hydrants can't be within a certain distance of the street. The light posts have to be within far enough away from the street because of accidents and things of that nature. So it's really important to pay attention to. If you're a civil engineer, they literally survey everything and try to figure out like where they can put all these different features, and it's just part of designing a city and everything. So it's kind of a cool little neat field to look into, guys. Use a lot of geometry in it. Explain how this plan allows you to find the distance. So it just basically does it because you're using angle, side, angle, so their corresponding parts are going to be congruent, right? All right, so we have another proof. Let's draw our T-table for our statements and reasons. Statements, reasons. So we have our given of angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. And those are all given. So angle 3 is congruent to angle 4. Oh, let's do that one, okay. So now, what else do we know? What are we trying to prove? Let's look and see what we're trying to prove. BCD. BCD. This whole half right here, we're trying to prove BCD is congruent to DCE. BCD. That's a typo. What are they trying to prove? BCD. DCE. They must be doing BCE. That's a typo, guys. They're trying to prove this equal to this. Make sense? So what do we know? We know that this is reflexive, right? So we could say CE is congruent to CE, right? Reflexive. So now we have angle and a side. We don't know anything else. And to be honest, we can't really do anything else. So the only thing that we can do is look at other stuff. So let's look at this triangle here versus this triangle up here, right? So they have angle, angle. Do you guys see this here is reflexive? So CA is congruent to CA. Reflexive. And then once we added that in, then we know that triangle CDA is congruent to triangle CBA by angle, side, angle. Well, if they're equal by angle, side, angle, then CD is congruent to CB. Corresponding parts of congruent triangles are congruent, right? Well, if those are congruent, now I have side, angle, side. So now I can do my triangle BCE is congruent to triangle DCE, and my reason is side, angle, side. Make sense? So I had to look at a different set of triangles to be able to prove something on what I was actually trying to prove. So I wanted to try to prove that this little triangle here is congruent to this little triangle here, but I didn't have enough information. So then I looked at this bottom half versus this top half, proved those two triangles congruent using reflexive. Once those are congruent, their corresponding parts are congruent, and now I have side, angle, side for these two. Make sense? Got to think outside of the box. Ready? Proof to verify that the construction for copying an angle is valid. Okay. So they gave you that AB is congruent to DE. AB is congruent to DE. They gave you that AC is congruent to DF. They gave you that BC is congruent to EF. So if they gave you all this, they gave you side, side, side. These two triangles are congruent by side, side, side. So you list all your givens, they're given. The two triangles are congruent by side, side, side. Therefore, corresponding parts of congruent triangles are congruent. Angle A is congruent to angle D, CPCTC. Corresponding parts of congruent triangles are congruent. Prove the triangle's congruent. They already gave you everything to do that. Therefore, the angles are congruent. Corresponding parts of congruent triangles are congruent. All right, so this is exactly what we just did. We proved them congruent by side, side, side. Therefore, the angles are congruent. Corresponding parts of congruent triangles are congruent. Look back at the construction of an angle bisector in example 4, Explore 4, on page 34. What segments can you assume are congruent? So I need you guys to open up your textbook to page 34. So we're going to do that really quick. So, what segments can you assume are congruent on Explore 4? So we know that AB, right? So this is bisecting an angle. We know that AB and AC are congruent, right? Because we opened up our compass to that specific measurement, right? So we know that these are definitely congruent. So here and here are positively congruent. All right, and then we move our mark to here and we go arc, arc. So we know that these two are going to be congruent. From B to G and from C to G are congruent, correct? So let's kind of just write this out. So if I have it, just to kind of show you guys. So far we know that these are congruent and these are congruent, right? What else do we know are congruent? So we know for sure these are, and then these are, right? We have a reflexive. So we know that this triangle is congruent to this triangle by side, side, side. Therefore, corresponding parts of congruent triangles are congruent, and it proves that it is bisected. Isn't that kind of neat? So when we have this arc, we know that these two are equal. Then we move our sharp point to here, make an arc, sharp part to here with the same opening, make an arc. So we know that positively this distance here and here have to be equal. And we know that that line straight down the middle is reflexive. So by side, 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 the triangles are congruent. Therefore, yes, it is bisected. We just proved the, that's just the proof for an angle bisector. So that is everything on your lesson today on example 4. So that was AC and AB, right? So I hope you guys enjoyed your lesson on 4.7, Use Congruent Triangles. Like and subscribe, and have a great day. Take care.